Thank you. So first thing, thank you, Jimmy, for organizing this meetup. I'm so excited about this meetup. It is great to see how we can run the first ever meetup in agriculture, sponsored by Voxel 51. This is a topic that we need to bring the attention for different, people, researchers, startups, and industry. And I'm glad that we were able to do this with this amazing panel that we have today. And thanks everyone for being here. I'm excited to share how we are brewing better AI. And I have an example about unlocking my coffee data set with FiftyOne. So let me move my slides. Okay. So I'm Paula Ramos, a passionate AI evangelist with years of experience in leveraging AI and machine learning to solve real-world challenges, particularly in agriculture. And today we will talk about coffee. And I think one of the main things that we have in mind is, all in our daily lives, we need a magical cup of coffee. So like Jim Carrey in Bruce All Might, alongside with Juan Valdez. So we need coffee every time. I need this magic cup of coffee. And I think that I'm not alone. So, but I also want to talk about the significance of coffee. And so, in the question mark here is, do you know that coffee is the second largest trade commodity in the world? It is the second one just after the oil. So that's amazing, right? So, and here is the production map, the coffee production countries. Most coffees grow in tropical regions, and we'll see a variety from Robusta to Arabica, with Colombia being renowned for its high-quality Arabica coffee. So if you think about Colombia itself, so we have around, coffee is just about lifeline. It's not just about a crop. So we are talking about small-scale farms. We have over 565,000 families, and 2.5 million people depend on it in Colombia, in South America. And it also covers almost 1 million hectares around the country, contributing significantly to our economy and social stability. So, and when I embarked on my doctoral thesis in 2012, I wanted to empower farmers, these small-scale farmers, to estimate coffee crops yields using something that they already have, their cell phones. So coffee production spanned to the entire year with peaks at different times depending on the region of the country. So farmers needed to know where to increase human labor, where they needed to put more people in the lots. By utilizing cell phones for capturing field data, I focus on user-friendly solution that farmers could quickly adopt and use. So this is one of the things that we need to think about in adoption. So, and to make this process, easier and familiar, I designed a device with a handle and button to connect the cell phone with a dedicated app. Pressing the button once will take a picture, and pressing the button twice will start and stop the video. By slowly moving the device over branches, we capture clear images. So videos enable us to create 3D point clouds, and pictures helped us in identifying fruits in 2D. So we then use this data to estimate yield of each branch, extrapolating it to the whole tree and eventually to the entire lot. And for sure, we were working in statistical models to make those estimations with agronomists and specialists in the field. So, and the research came with the fair share of challenges. The long timeline was the major factor. So biological material is only available every 9 months. So we need to follow crops weekly. We needed to follow crops weekly, from flowering to harvest, tracking every single branch and fruit weekly. The weather and land conditions in Colombia's coffee regions were tough or is tough to navigate. So plus back then, we didn't have the AI tools that we have now. So we had to innovate with what we have at that point. So if you think about the process, developing this application involved a detailed timeline. So the first thing, data acquisition, took around 9 months, and we were running multiple protocols at the same time in different lots, in different areas in the country, given for the biological cycle that we have. So the next step, we will spend about 3 months on data curation. So we have some metadata there, like, for example, timestamp, geolocation of the branches. We have also the number of fruits that we have per branch, and we were following that weekly. And following by another 3 months of data labeling. But at this point, I want to make a note. And at that time, I needed to create my own annotation system because I didn't find any annotation tool to help me to create labels per frame in a sequence of frames in a video. So that also was a long work there. So different time right now where we can see a lot of tools. So, and then training the AI model took additional 3 months, exploring the data set, exploring the features that I need to extract. So now the things are a little bit easier because we can, with embeddeds, we can extract the feature vector more easily. We can explain the AI models that we have. But at that time, that was a different story. So finally, testing, retraining, and deployment extend to the total of around 2 years per protocol. So that means that we could have an application for AgTech at that time between 12 and 24 months. So the journey reflects the complexity and dedication required to bridge such an innovative solution to life in AgTech. So, and to achieve this, as I mentioned before, we were working with specialists in statistics as well to estimate the yield. But we needed to have a foundation in computer vision techniques. So this involved creating decision-adjust images and reconstructing 3D models. We filtered out outliers from 3D point clouds and extract features to classify different characteristics. We also detect, counted, and estimate volumes in 2D. Additionally, we perform geometric analysis, creating models from various shapes and extract geometric forms using superquadrics. And finally, we apply ransack for individual segmentation. This comprehensive process was essential for accurate analysis and yield estimation. So at that time, and even before I joined to Voxel 51 4 months ago, I was trying to perfect my AI models to detect these fruits, But I would like to have time and back to the past to say I want to back to the future, and I will go to revisit all algorithms and understand that this is not just about collecting more data, that I can improve the quality of my data that I have to improve the model's quality. So, and let's talk about what we can actually do with 51. So I have created a coffee data set straight from the mountains of Colombia, and this is for educational purposes. So over 1,500 images captured in different stages of coffee fruits, immature, mature, semi-mature, and over-mature. Around 10% of these are annotated, and we have got both segmentation and detection labels, which means that we are working with instant segmentation, and the dataset follows COCO format. So it is fully compatible and ready to roll with 51's tools for curation, filtering, and model evaluation. So let me jump. Let me see if this is working. Yes. Let me jump to, for the ones that are not familiar with 51, so this is the 51 app. So 51 has an SDK where you can programmatically inspect your data set, but also you can visualize the data in the app. So in here, I have the data set that I am talking about, and I also make a calculation of the uniqueness of the images. So you can see here, I have a number here. That means how unique is this sample in my data set. So I can, for example, in this part of the app, I can see all the metadata and how can I integrate also this value of uniquenesses. So I can see that I have, these images are unique in my data set. But I also can explore, for example, labels. If I also have timestamps, I can also include the timestamp in the metadata. Whatever metadata that you want to include, you can include this here. And this is unstructured, an unstructured data set, and this is great. So you don't need to lose your mind trying to find, okay, this timestamp that I have when I took this information, what kind of weather conditions I have. We can put everything here and just explore and inspect the data set within the metadata as well. So something that is really cool with FiftyOne is also you can explore the embedded. So let me just delete this. So let me show you something. So we have embeddeds. So embeddeds are a way to change the representation of the images. So basically, with all this data set, I can explore different conditions. So for example, maybe we can see these outliners here. So I can interactively, I can just check what is going on here and see this in the visualization part. So I don't know what is going on here, so I can see that maybe different lighting condition, saturation with the sun or something like that. And it is really important to have everything in my annotation subset to have a good performance of my model. So, and this is just an example about FiftyOne. So FiftyOne, you can easily filter by class, visualize predictions, ground truth, explore annotation, quality, and even pinpoint where models fail. It's like having a magnifier for your data set. You can take a look of everything. So let me come back to the presentation. Okay. So now, if you ask me about where are you going, Doc, I will say I'm returning to the future to improve my coffee data set quality with FiftyOne. So in the past, I used the same data set. So I faced challenges with the model quality, even using active learning for selecting the proper samples. So achieving just around 70% of accuracy. And by focusing on data-centric AI and annotating the proper samples, we can enhance both the data quality and the model performance. So, and with FiftyOne, we can really boost our results. So, and I will show you how. So, with the platform itself, as I mentioned before, you can curate your data, you can visualize and analyze data set easily. But also FiftyOne can help you to streamline annotation workflows, find and fix labeling mistakes, and identify and correct model failures. So FiftyOne is the only open source data-centric AI solution, making it accessible and versatile for various AI applications. Today, we are talking about agriculture, but this is also applied for different kind of verticals and sectors. So, and now, and FiftyOne also plays a crucial role in data-centric AI. So when we think about this complete pipeline, so FiftyOne enables us to load and filter data sets, visualize the embeddeds, as I showed you before, compare models through the model evaluation panel that FiftyOne has. And additionally, FiftyOne supports the MLOps pipelines that you have already in your system. So making it a versatile and powerful tool for improving data sets quality and model performance. So now, let me show you something. So we can explore the data set in multiple levels. So we can load data sets from your local disk. We also have connection with Hugging Face Hub. And we also have an extensive FiftyOne dataset zoo. And in this case, I'm loading my data set with Hugging Face. Also, I will give you access to this content so you can take a look of this code and you can see if this is usable in your site with your own data sets. So in this case, I'm using my own hub, the data set that I have, and I'm using and programmatically using the SDKs, but I also can see the app. Let me switch my tab here. and I will show you something. So, and I can see all the stuff that I showed you before is here, but I want also to show you something that is really cool. So FiftyOne offers a range of interactive plots through plugins. So we have plugins. And this is really important in agriculture when we want to create a geolocation of our information. So in this interactive plot, we have the availability to geolocate data on maps. So let me I will load again this data set. Okay, I have here the whole data set. So I will open the interactive plot with plotting map. That is an interactive plot with a JavaScript base. And this allows us to explore our data set based on the geolocation that we have integrated here. So I already have this plugin running with the whole data set. I need to define the market size field that for me will be the maximum number of fruits in the maximum maturation that I have in one branch. And the color size will be the stage. It will be over mature, semi-mature, immature. And the text that I want to show in the point will be the string of the counting of the maximum maturation stage. So, and as you see here in Colombia, South America, so we have the map here. So I'm just zooming in. It's a small lot. And let me show you something. So let me just make this bigger. And I think that will be yes. Okay. And I think that this is really useful for in the agricultural perspective. So, and the good thing here is I can interactively play with the map and see and visualize what information I have there. So for example, I can select the box here and just mark this and see what I have in that specific area. And these are the images that I have for that specific point. It's not that amazing. So I think that this is really good. So is this dynamic visualization, I think that help us to understand better our data sets and also try to find some edge cases that we need to include in our data set. So, and also, FiftyOne support different variety of computer vision tasks. So we have classification, detection, segmentation, key points. We are supporting image, video, 3D point clouds. And in my coffee data set, I have segmentation task with mask and also bounding boxes, that is instant segmentation in COCO format. And 51 seamlessly support this, making this easier to handle and analyze complex data sets. So it is really important to see something. So 51 also excels at supporting various models through its model zoo. So we have 51 model zoo. And this provides a powerful interface for downloading and applying pre-trained models to our datasets. We have a native access to hundreds of models, and we stay on top of the latest AI trends. So for example, SAM2 is available in 51 and offering high performance for both images and videos. So it enhanced image segmentation, introduced advanced video capabilities, and improves generalization with a faster inference, sorry. So we were able also to implement this SAM2 directly using 51 with the model zoo. So the thing that I need to do was just install SAM2 in the repository of Meta to have all the dependencies that I need to have for running the model. So, and this is more or less what I can see, Here is one example, I'm loading the model using load zoom model and just calling the model that I want to use and the version. So in this specific example, I am applying it by prompting the ground truth boxes that I have. So I have the ground truth boxes in prompt field, that is category segmentations, and I'm creating segmentations. So basically, and this method allow me to, evolve category segmentations in segmentations. And you can see that we have, if we can see you can see the batch results. You can see that I have these two categories in my data set. So, and now we can use SAM2 in a really good way. We have the SAM2 coming from Model Zoo. We can generate those match predictions and also visualize the results. But what about this? How we can improve the data quality using SAM2? We can pre-annotate this data because it is so demanding. It's a high demanding labor to annotate. Semantic segmentation, instant segmentation is so demanding. So I can use SAM2 to pre-annotate the data, but I don't want to pre-annotate the whole data set. So I need to select the most unique images or samples that I have on my data set. So then after I select those images, I can run the SAM2 and pre-annotate the instant segmentations and the labels. Then I can polish the the annotation in CVAT, and then we can just retrain the model. So, and this is how this is working. So with the embeddeds, I just realized that the data set that I annotate with active learning for a while is not covering all the edge cases. So I already annotate this with active learning, but it's not covering the whole edge cases that I have on my data set. So when I run uniqueness that I showed you this before, I realized that I also have unique images in different areas that I didn't select. So using this functionality, I was able to compute the uniqueness and select the most unique images, 100 unique samples in my data set. I send these 100 images. I just see these 100 images and try to take a look of that using also FiftyOne. And I see that, okay, maybe I need to run some filtering detections just because I have maybe some leaves or I'm just taking some information out of my region of interest. So I was using filtering detection, applying size, shape, and position filters. And I also assign labels using a cosine similarity. In this case, I applied the model that also is coming from Model Zoo, but the label field is equal to auto. So in that case, automatically is making this. And this is a really good approach. And then I can see that after the filtering part, I was able to eliminate those undesired labels. But still some undesired labels are there. So I need to send these 100 images back to an annotator system. And we have a native connection with CVAT. We have more integration, but CVAT is the native integration that we have with an annotator, and CVAT is also open source. So I was able to eliminate those undesired annotations, but I don't need to spend too much time making this manually. So I was saving a lot of time. And then I was sending this information to the system that I was using for training, that I was using Intel Getty. As you know, I was working at Intel, where we have Intel Getty, that is basically a system that you were able to annotate and train your models with a few images. So working with this, I just pushed these 100 images there, and then I was able to see that something was really cool, something that I haven't seen before, even if I was working several times with the same data set. Remember, I told you at the very beginning, maximum score that I saw in this data set for this kind of detection was 69%, almost 70%. So with the new unique samples, I was able to score the performance of the model in 90%. And this is the huge evidence that for having a better model, I don't need to increase the data set. I need to identify proper samples in my data set. So I was able to see that evidence in Intel Getty, but also I was able to see this evidence using the model evaluation panel that FiftyOne has, where also I have the new model as a winner in comparison with the previous model. I also was able to visualize all the predictions. So that means that 51 is great for raw data, ground truth information, and also predictions for different kind of computer vision tasks. And finally, I was moving too much in the model-centric approach, but now I think that my selection and my choice is move to the data-centric approach, where I can reduce biases and errors, where I can be focused on data set quality and have a better cost-efficient optimization. I don't need to think about increase the model complexity and have a high computational cost. And think about that also our end user is a small scale farmer. So they don't have maybe the capabilities to have a specific or a big computer to run these algorithms. So now, this is the paradigm for everyone here. So I will move for sure. I will switch to the data-centric AI approach instead of the traditional model-centric focus. So I will go to this line, and maybe others will go to Lord of the Rings. But I will invite you, to move forward to the data-centric AI approach. And remember that I told you at the beginning, 12 to 24 months to deploy one application for AgTech. So with the seamless integration that 51 has, for sure, I cannot control the biological material with 9 months, but the rest, annotation, curation annotation, training and retraining, it could be in order of weeks instead of months or years. And this is a huge win for all of us. So just wrapping up stuff here is, I think that we have a lot of benefits for working in this new era of visual AI, where 51 is one of the main actors, because we can save a lot of time. We can reduce the cost of this process. We can improve also the results, the accuracy, and also we can improve the answer or our making decision systems. Finally, we will have a coherent visual AI platform that is called 51. And this is done by a company that is called Voxel 51, sponsoring this meetup. And I really want to say thank you to the lead maintainers of this amazing open source toolset. We are making visual AI a reality. So, and to all of you, what is next? So please, if you already have a data set, install 51. It's simple as pip install 51. If you are interested to use part of the things that I showed you today, you can also access the coffee notebooks that I create for you. You can also join our community in Discord, that is great, and attend our events. And if you want to continue this conversation with me, follow me on LinkedIn, and I will be more than happy to have a meaningful conversation with you there.
Fantastic. So we'll go ahead and include those links that were in the QR codes. We do have, let's take one quick question and then we'll jump it over to Guy. We take the rest of them offline. Question. When you say we need unique and quality data over large amounts of data, does it mean that if I have a data set with 10,000 images, but only 5,000 unique images, should I only use the unique samples for training?
Yes, we don't need to use the whole data set for sure. And that for sure depends on the protocol that you are using. So in my case, I was using 10% of the data set, but I increased that a little bit. And now I could see the boost. But yes, using just the unique samples will make the model performance much better.